let's do this. So what's on the menu for today? So on the menu today is graphing interpretation and also what we call horizontal shifting of trig graphs. So if we look at a basic trig graph, like say y equals sine x, it is possible to do a transformation where I shift it horizontally. And what I want to ask you is, what effect do you think making x plus 30 as the input to the sine function has on the graph? Do you think it moves it 30 degrees to the left, or do you think it moves it 30 degrees to the right? That's what I want to ask you. Let me know in the chat. Let's see what people say. Is it going to go to the left, or is it going to go to the right? So the basic sine graph would have sort of go like 90, 180, 270, and it would start at 0 and go up to 1. Let's do this again. So I'll go 1 there. Minus. It would look like this. That would be the basic sine graph. This one over here. Now, if you make it sine x plus 30, what you'll observe if you drew the graph, and let's do a different color here. So if we were drawing this one, actually the graph would start over here. And so it looks like it's been shifted, well, it has been shifted 30 degrees to the left. And so then what will happen is that it'll always be 30 degrees behind the normal one. So it'll look kind of like that. And then it would go like that, and then kind of like that. So this is called a horizontal shift. So what I want to do is I want us to use our calculators to have a go at this. And I will draw in, I want to do a comparison. So if we had to think of what y equals cos x looks like, I'm going to make this 1 and this minus 1. The basic cos graph will look like this. And I think most of us are familiar with the basic cos graph. I'm not going to worry about working that out too much. But when I'm drawing it, can you see how I'm drawing in these 4 quadrants? Now, what I want you to do is I want you to use your calculator to help you. So let me quickly bring my calculator onto the scene. And I want to see, can you, using the tools that we've used so far, I want you to try and draw the graph of cos y equals cos x minus 45. And I'm pretty sure most of you know from the previous lesson how to input that in your calculator. And I just want to get a sense of what it looks like if I draw this graph and how I can use my calculator to do that. So just let me know in the chat when you're done trying to do the blue one, just say done. Just give me an or a D for done when you have to go with that. And the domain we're going to use is going to be minus 360 to plus 360. That's what we're going to use as our domain for this. Now I wonder what we should make our step size. What should we make our step size for this? What do you think? I'd love to know what step size do you think we should use for this one? To try and help us draw this graph of y equals cos x minus 45. Yeah, I mean, it doesn't seem, based on what we were doing in previous lessons, it seemed like 90 would be a good idea. Let's just see what happens if we put 90 in as the step size. Now, one of the things that happened is I have quite a messy looking table. Let me just have a look if there are any nice, neat numbers. So now, even though when we draw the cos graph, we normally draw it in these quadrants of 90. If I look at my table, it looks a bit messy. So I'm wondering if we had to modify the step size. So let's say we go back and we go minus 360 plus 360. I want to try and get a clearer idea of what the path of this graph looks like. What do you think might work as a step size if I don't use 90? Because 90 was feeling a bit messy. What would you try next? Yeah, 45. I think so. Like 45 might show us, or 30. 30 could also work, but I'm going to stay with 45 for now. So let's say 45. And what I notice is when I look at my table, sure, at minus 360, the graph is positive 0.7 type of thing. So it's going to be up here. But what's nice is at minus 315, I'm at 1. So that's a nice, neat, round number that's easy to use. And let's just have a quick look here. So minus 225, it's at 0. So that is over here. And what that makes me feel is like if I connect up these graphs, that's going to help me draw the graph. So what I'm going to suggest is use a step size of 45 and then see if you can draw the graph using that step size. I'll give you a bit more time and then just put done in the chat when you feel like you're done. It feels like by making the step size smaller, it was easier for us to see which points it would go through. So over to you guys for a bit. So Andile, you probably would have got 17 points or quite a few points. What I'm going to suggest is instead of plotting every single point, Andile, what we're going to do is I'm going to look for the points that have whole numbers and just put them in. So like, for example, minus 135 minus 1, that's like a nice, neat one. So I'm going to leave out the one after that because it's a bit messy. And then I'm going to say minus 45, 0, which is going to be here. So what I'm doing is I'm almost leaving out every one in between because, you know, it's a bit messier and I just wanted to get the points kind of in the exact spot. So like I'm leaving out, okay, at 0, I don't have something, it's a bit messy, but I have one at 45 and it's 1, which is up here. And so what I'm doing is I'm just putting in every second dot. So what have I got? 135, 0. And then I've got 225 minus 1, which is down here. And then 315 is at 0. And then at 360, it goes to 0.7. So it's going to be not quite at 1. It's going to be kind of like up here somewhere. So again, I'm going to wait until I see some dones in the chat before I move anyone. But all I've done, it seemed like by making the step size smaller and by just choosing every second dot, it was a much easier way to plot this point. Okay, so using it, that's a trick that we can use. If you are shifting horizontally and you're getting messy numbers, make your step size smaller and then just plot every second or third point to give you the shape that you need. And that's a very handy trick to kind of, So let's see if my graph makes sense. Now, the good news is, if I look at the red and the blue, it looks to me like the only difference is that the blue graph is 45 degrees to the right. It's almost like the red graph moved to right by 45 degrees, and that's exactly what I would have predicted, right? It's exactly x minus 45 should move the graph 45 degrees to the right. And I think there are other ways to do this. The other way you could have done is just moved 1 point to the right and then drawn increments of 90. But I think this method of making a smaller step size and then plotting every second point or every third point would make a lot of sense as well. Give me a thumbs up if you're following what I'm doing. Give me a thumbs down if you feel a bit confused. Okay. So let's move horizontal. Like all of the only thing that I've done differently in this case is I've made the step size smaller because it helps it for me. It's easier for me to see where the dots are going to be. And then I've only read off every. So if I look at my table, the only point, like the 14th point I was plotting, and then I was also plotting the 16th point, and I was plotting the 12th point. And that's because they have nice whole numbers that are easy for me to plot. The only ones that were a little bit messy were like these ones at the end. And that's, that's unavoidable type of thing. Okay. Should we do another one like this? Let's do another one like this. So just so we get the hang of it. So the normal tan graph has asymptotes at 90 and minus 90. And because the period of the tan graph is 180, we're going to have asymptotes over here. So I'm just drawing this from memory without my calculator. Let's just do this. And we know that the shape is going to look like that. Notice how I'm kind of drawing it in two halves. What is your prediction about the blue graph? What do you think is happening when we compare let's say the red graph compared to the blue graph? Okay, so Kayleen, I'm going to go through and someone say, I'm going to go through this one exactly with you. And so just stay with me now because I'm going to work through this kind of from the beginning. So I just want to ask for a prediction. What do you predict about the relationship between the red and the blue graph? Yeah, it shifts it. Actually, I think the x plus 45 will shift it to the left because it always goes the opposite way around, right? So like x plus 45 actually should shift it to the left. The blue graph moves to the left. Yeah. Okay. Now, that's my prediction. Let's just see it on the calculator. So we go tan alpha x plus 45. Now, we are doing our domain from minus 360. So just shout, if I'm losing you, Kayleen, please do let me know in the chat. Have you followed everything I've done there? Like if I go back again, I typed that in and I'm using the alpha x to help me go. How do I know if it's horizontal or vertical shift? Okay, a vertical shift would be a number like out here at the end, like +2. The moment it's inside the bracket and there's a plus or minus, it's going to be a horizontal shift. Okay. So if we then go equals, and then we go minus 360 plus 360. Now, here's the thing again. What size should we make the step size? I'm going to make it 45 because I want to see it's just easier to see a better perspective of what's going on here. So if I make the step size 45, what is that telling me? Well, First of all, can someone tell me what the minus 315 is telling me? Why is it saying there's an error? What's that secret code for? Asymptotes, yes. So what this is saying is that there is actually an asymptote here, and that makes me very happy because you can see that this asymptote has been moved 45 degrees to the left. Now, what other points can I plot? Yes, Toba, I agree. Emmanuel, I agree. So, Sinosipo, we are sort of guessing it, but basically the step size is always going to be either sort of 90, 45, 30. There are some basic rules, but sometimes you can change the step size. All the step size is telling you is how much spacing there is between each point. And so we choose the step size in a way that makes our life easier. Normally, in the sine or cos or tan graphs, we make the step size 90, unless it's to our advantage to make it smaller. Okay, so it's not guess so much as it's a judgment, maybe is the word I would use. Okay, let's go. Minus 361. I'm going to use 1 as being here in the scale. So there's my dot. Then I've got 270, and that's at minus 1. So let's make a dot there. Then I've got minus 225, which is 0. Then I've got minus 181, which is here. Then I've got minus 135. Now, this is actually an indication of another asymptote. Now I've got minus 90, minus 1, which is here. I've got minus 45, 0, which is here. I've got 0, 1, which is here. I've got 45 and error. Okay, so that. I've got 90 and minus 1, which is down here. 135, 0, which is here. 181, which is here. 225 error, which is here. And what else have we got left? Let's speed up a little bit. 270 minus 1 down here. 315, 0. And then 361, which is here. And the good news is I know I can't cross the blue asymptote. And so that's going to be my tan graph there. And then here, okay, I should have gone through there, but you get the idea. And then what's happening here? So I do this. And then over here, I'm doing that. And you can kind of see that this is going to go up like that. Now, what I'm loving is I can see that the blue one is always 45 degrees behind the red one. And the reason it's happening is this. Okay. Give me a thumbs up if you're understanding the horizontal shift a bit better now. Give me a thumbs down if you're still feeling a bit confused. Okay. So again, remember, you can rewatch these videos, hey? And again, you've got this tool called the calculator, which is kind of your friend as you work through this. And my advice would be just keep practicing old exam papers by using your calculator, working on your strategy, and before you know it, trig graphs will get a lot easier. Okay, now, before we get to the halfway point of this lesson, Kat, could you be more specific? Is it possible to have a sort of sine graph? What do you mean by that? So let's have a quick look at a graphing interpretation question before I get to the halftime break. So in this old exam question, it says we've got the graphs f of x, which is cos x. And so that is this one over here. And you've also got g of x, which is this one, and it goes like this. Now, I want to ask, what is the transformation that has happened on the green sine graph? What type of transformation has happened to that graph? What is the x plus b doing? What is it doing? Yes. So this is a horizontal shift. This is a horizontal shift. Can you tell me what the value of b is going to be based on looking at the graph? I want you guys to take some time and tell me, what do you think the value of b is going to be?
Mr. Ace?
Yeah.
Kat says that they meant having a sine and a tan graph on one Cartesian plane and then being asked questions about that.
You can, yeah, you can. It is absolutely, yeah. I'll show you. We're going to do one like that later in the lesson. Yeah. Okay, so I'll give you a hint. The sine graph normally starts here and it goes up to there. If you look at where it's now starting, it seems to be starting kind of over here. It looks to me like it has shifted 30 to the left based on where it would normally start. Can you see how it's moved 30 degrees that way? Now, what is x plus what would shift the graph 30 units to the left? Okay, remember, it always works a bit backwards. So if you want to move 30 degrees to the left, what does b have to be? And remember, it looks like you're going in the negative direction, but what's going to happen is you are actually going to get this graph, you need to have g of x equals the sine of x plus 30, because plus 30 will move it 30 degrees to the left. So b must be positive. Yep. And so this is an example of where they give you the graph and you need to be able to work backwards to get that bit over there. Okay. But you can kind of see it, right? The other way of doing it would be to sub a point in, but that's a little bit harder, although not impossible. So what you could do is you could say, like, if you choose a point on the green graph, right? So if you look at this point here, that point is the point 61. And if I put it into this graph, so if I go 1 equals the sine of x, oh, x is going to be, sorry, 60. So it'll be 60 plus b. I could then solve this as a trig equation to find what b is. Okay, so that's the other possibility. But I think the easiest way is just to visually look at it and see how much it's moved left or right. And so that's what I'm going to recommend for now. Okay, second part of the question. Can you write down the period of G? So what is the period of this green sine graph? I want your answers in the chat. I don't mind if you're wrong or right. I just want to see that participation. So Quirin, it could be that your calculator is on radians and not on degrees. So my advice would just be to put it back to degrees or hit the reset button on your calculator. Okay, 6.2, the period is indeed 360 degrees. This is a sine graph and its period has not been changed. And so it remains 360 degrees. Okay, let us take a break. We're going to come back and finish this question after the break, but I think we've worked hard And so we need a break. So everyone turn those cameras on and let us stand up. And, oh, I can feel my quads are happy with me that I stood up. Make your quads happy too. There we go.
Please turn on your cameras, guys. Let's see your lovely faces.
Your faces. I want to see the happy people of the room. And what we're going to do is we're going to start by kind of standing on your tippy toes. So your calves should be like raised. And then I want you to try and point up and touch. Oh, even I can't do it. Try and touch the roof of your room. And if you're struggling with that, just stay flat on your feet and just stretch up, and you'll just feel your stomach muscles. If you can really do the ninja move, stand on your toes, see if you can balance and reach up. It's a good one. You can feel how like body wants to fall over. Feel my calf muscles, yeah. Okay, and then let's do a little neck stretch. I feel like we haven't done that for a while. So just give your neck a little rest to the left. And then give it a little rest to the right. Maybe do a little bit of a rotation so that your neck can just get a little. So go the one way and then go the other way. Oh, that feels nice actually. Okay, and then let's roll the shoulders a little bit. So roll them backwards. And let's roll them forwards. Okay. And then let's put our arms out and some nice small circles going forward. Nice and small circles. And then we're going to go into slightly bigger circles just to get our arms moving. And then change direction. So you're going backwards now with big circles. And then going into smaller circles. And nice and small. Okay. Then shake out your arms like they're nice and rubbery. So pretend like they're made of, I don't know, licorice. Do you like licorice? I like licorice sometimes. So shake them out. So you can do the wave. Who knows? Maybe you're better dance than I am. And then shake out your legs. Oh, it feels so good. And then let's just stretch out this one too. Do that. And then do your other shoulder as well. Okay. And then let's get our heart rates up. You really can't beat jumping jacks. I'm not going to be doing mountain climbers given this current position. So jumping jacks is just the way to go. And let's just do 15. So we'll do 15 in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. And your body should now be feeling some oxygen and some blood flow moving around to bring your cleverness to the surface. And let us do a little, oh, I can feel my heart pumping. See if we can do some mass 24 before we finish our break time. Who feels like they can solve a mass 24 puzzle? Over to you. Who would like to claim the red one or the yellow one or the blue one?
Dun, dun, dun.
Yeah, exactly. Who would be our mass 24 champion? Or champions, plural. Red. Okay, so Matai, tell me what the red one's answer is. Give it. How do we get to 24 using 8, 8, 4, and 2? What ways and means do we have of getting to 24 using the red card? So Emmanuel, can we do knee-ups for the cardio exercise? We could do knee-ups, yep. So I'll bear that in mind for next time. I'm just make sure I don't fall over when I do it. 4 times 2 plus 8 plus 8. I like it. 4 times 2 plus 8 plus 8, which is really just 8 plus 8 plus 8, which is 24. Yeah, looks good to me. For the yellow one, we have, Nkosi has said, 7 minus 5 times 8 plus 8, which is 2 times 8 plus 8, which is 16 plus 8, which is 24. Yeah, looks great. And Adila has also said for the red one, we have 4 times 2 times 6. Oh, and then, okay, but I don't think we have those numbers on this card today. Oh, for the blue one. Okay. So the 4 you can get by adding the two 2's together. So that's fine. And then you have 4 times 2 times 6. I'm not quite following you there. Maybe there's a little. For the blue, 2 times 3. Okay, it's 2 times 3 is 6 plus 6. 2 times 3 is 6 plus 6. Oh, I see. 2 times 3 plus 6, which gives us 12, which is in a bracket. 2 times 3 plus 6, and then times by 2 at the end, which would give us like 12 times 2, which is 24 for the blue one. Yeah,
Nicely done, guys.
We smashed that in like 3 minutes as a group. Well done. Okay, let's go back to the lesson. So we were dealing with this old exam question that I had up on the board, and we want to look at 6.3. Now, 6.3 looks like a bit of a mouthful, but it's actually not that bad. So let's just clear away some of the clutter here, just so we can find our bearings again. And what we see is that it says, write down the values of x in the interval minus 180 to 90. So let's just make sure we know where that is. Minus 180 to 90 would just be this bit here. And what I want to give you advice is that having some colored pens or pencils in your tests and exams is helpful, especially when you're having to interpret language that's quite complicated like this. All of us can understand that you start here, you go there. That's easy to understand. But when you see values of x in the interval, blah, 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 that makes it a bit more scary. So it says, the question says, write down the values of x in this yellow strip for which f of x minus g of x is 0. Now, knowing what that means is a little bit tricky. But if I ask you for the equivalent statement for which values of f of x is equal to g of x, well, that is exactly the same statement as that one, because I've just moved the g of x across. So can you tell me, in this yellow strip, when is the function f equal to the function g? For what values of x? I want you to look at the graph. For what values of x, what numbers on this yellow line is the graph f equal to the graph g? So I'm seeing some suggestions coming in. Keklecho has said minus 150. So let's go to minus 150. Oh, you're quite right. Look at that. So the two graphs intersect at minus 150. And Nompilo has said at 30. And Nompilo, I see exactly what's going on there. So that's 30. So the answer for this is just going to be x is minus 150 or x is equal to 30. Yeah, so that's not so bad. So once we got the language part out the way, and we could find it saying, look, for which x of which of the yellow strip is f equal to g? And that was it. That was an easy way. So sometimes taking the statement they give you and translating it into an easier form of the same statement. That's a trick that is very, very useful. And I want to encourage you to remember. You can always take a statement and make an equivalent one that is simpler. And a similar thing is going to happen in 6.4. So it says, for which values of x in the interval minus 180 to 90, so again, it's the yellow strip, is sine of 90 minus x. So sine of 90 minus x greater than g of x. Now that looks a little bit scary, but can someone tell me what the sine of 90 minus x is actually the same as? I feel like I've seen it in what we call reduction formula. So Mpo and Nompilo and Emmanuel and Nkosi have all said that they think this is the same as the cos of x, and I completely agree with you. Now, if I look at this question, I've seen the cos of x somewhere before. I've seen it up here. And what that means is that this statement over here, cos of x, is the same as f of x, right? If you look at the top, f of x is equal to cos of x. And so I can rewrite this rather nasty looking statement by saying, where is the f of x greater than the g of x? And what that is saying is, look, if I look at the graph f, let me give the f the color purple. So here is the color purple here. That's the f graph. That's f of x as we see it going along. G of x can be the green one. So let's go like this. This question is saying, for which values of x, so maybe I should use yellow to keep my thing the same, for which values of x is f of x greater than g of x? Or another way of saying that is to say, when is the purple graph above the green graph? So when is the purple graph above the green graph? Who would like to give me an answer to that? Put your hand up or put it in the chat. Where is the purple one above the green one? It feels like they're the same over here, right? So at these points, they're exactly the same because they're intersecting. I want to know, when is the purple one, for which x is the purple one above the green one? So I think the purple only gets above the green over here. So it's almost like from here to here is when the purple is above the green. And they're the same at minus 150, they're the same at 30, but between those two values, so for 6.4, it feels to me like I'm looking for x values that are greater than 150, but then they're less than 30. So between minus 150 and 30, f is greater than g. Or another way of writing this in another notation is to say minus 150 to 30. And that would be the answer for 6.4. Give me a thumbs up if you follow the argument. Give me a thumbs down if you feel a bit confused by that argument. Okay. So let's have a look then at 6.5. It says the graph of h is obtained by shifting f 3 units upwards. So they're saying, look, there's this new function h of x, and the way we get it is we take whatever f is, so f of x is just cos x, but now I want to shift it up by 3. So in this case, the plus 3 is just sitting on the end here. So we've created a new function by saying whatever f was, add 3. And what they want to know is, what is the range of h? So if we take this new function h, what is the range of h? Now remember, the range is the y values that are involved. And if I look at this graph, if I look at f, currently it feels to me like the range of f is between here, which is the highest point, and between here, which is the lowest point. So currently for f, the range seems to be between -1 and 1. I want to know what the range of this new function h is going to be. Let me know in the chat.
Mr. S,
Yeah.
can you take a question from Bongi Kosi?
Yes, I can. Absolutely. Go ahead, Bongi.
Hello, sir.
Hey, how can I help?
My question is that on question 6.4, the question is that if sine of 90 minus x is greater than g of x, so do we say greater or equals because you included
Okay.
include one?
Yeah, a very good question. Okay, here's the important bit. Here's the important bit. It cannot include here. The way this question has been asked, because it says when it's strictly greater than, then these symbols over here cannot have equal signs as well. They must be greater than signs themselves. Okay, so it would be wrong to include this bit for that question, because the question said, where is it strictly greater than, not where is it greater than or equal. Now, it would be equal at -150 and 30, but that's not what the question is asking for. It's asking between those two red dots, which is why it's not going to include the endpoints. And that's why there's a circular bracket here. Cool. Does that help?
Thank you, sir.
Cool. Pleasure. Thanks for the question. Impor is asked, we get 3 marks for writing just that. You do Impor because it takes a lot of thinking to see that. You had to do a lot of thinking work to understand what the question was saying. And then for 6.5, so what is the answer? Well, normally the range is -1 to 1, but everything needs to move up. So normally it's -1 to 1, and it includes the endpoints. If everything goes up by 3, it should now be just from 2 to 4. Or you can just say like this, and now it does include the endpoints. So those are the 2 ways you could say it. So because the range includes the endpoint, right? So like if you look at f, it gets all the way up to 1 and all the way down to -1. Sorry, there shouldn't be -2. There should just be 2. You need to include the endpoints when you're talking about the range. Okay. And so the answer would be between 2 and 4. Cool. Okay, let's move on and do one more here. So let us look at this type of question. So earlier in the lesson, we were asked about whether we can ever have a question where we have 2 types of functions. So let's have a look at this question. Let's read it, and let me even zoom in a little bit so it's easier for everyone to see. And let's just start with just what's going on here. So it said the graphs of functions f of x is a cos b theta. I want you to tell me what are the transformations that are happening in f. What are the 2 transformations that are happening in f, and what is the 1 transformation that is happening in g? Tell me in the chat, what are the 2 changes that are happening in f? What are the 2 changes that are happening in g? Okay, now, so Impor said quite correctly, so the A is it's a amplitude change or vertical stretch. So the A is a vertical stretch. The B is a period change. It's changing the period of the cos graph. And then for C, which is related to the tan graph, that is also an amplitude change. It's going to stretch it upwards. Okay, now here's your question. Write down the range of F. What is the range of the graph F? Write that down for me. So it looks to me like that's the lowest value it gets to, which is -3. And up here is the highest value, which is 3. So the range has to be y is greater than or equal to -3, less than or equal to 3, or you could write it like that. Okay, so that's not so bad. Then it says, if m -45 minus 1, so m is actually sitting over here, if m lies on the graph G, determine the value of C. So you've got this y equals C tan theta, and they are saying, look, there's a point that lies on this graph. That point is -45 minus 1. Can you tell me what the C value is? What is that value going to be? So I was thinking in this case, because it's not obvious, if you look at how quickly it's rising here, the safest way to do this is just going to be to say, look, -1 equals C tan of -45. Notice how I just took a point that is on the line. So there's -45, it's going in here. Here's my -1, it's going over here. If I want to find what C is, shouldn't I just do this in my calculator and then see what C says? That's like a tongue twister. See what she says. So what do you guys get if you do that in your calculator? -1 divided by tan of -45. Yeah, you just get 1. That's it. And that makes sense to me because the normal tan graph actually is at 45 degrees is 1. And so they've been a bit sneaky here. C's value is just 1. Okay. Determine the coordinates of Q. Okay, we don't really have time for that right now. How would I find that one? Okay, I'm probably going to have to use trig equations for now. So, I haven't got to that one. Let's just do 6.3. Oh, we've done 6.3. Have we? No, we haven't. Apologies. I'm losing the plot here. I want you to try and find me what A and B are. So I'm going to repeat now, Wenje. So for the rest of us, can you try and find what values of A and B are? So for 6.2, what I did was I said, look, the graph G, which is this graph up here, G of X is equal to C tan theta. And I'm trying to figure out what C is. And I took a point that is on this graph, which is -45 minus 1. And I just said, look, if I sub in that point, so the thing I'm subbing in is the -1 and the -45, I can actually just move the tan of -45 to that side and then put that in my calculator. And what you actually get is 1. So I hope that helps. Okay, what is A going to be? What is B going to be? So we're trying to figure out up here. Okay. So A is amplitude change. And so what do we think the amplitude is going to be? Now, one of the ways of finding amplitude is actually to ask what the range is and divide it by a half. So that's the one way of doing it. So you could say to yourself, look, if you look at the range, it is 6 units big. And what's half of 6? The other way to do it is to ask yourself, how far does the cos graph normally go in 1/4 of a cycle? And in this case, it's gone down by 3 units. What do you think the value of A in front of this cos graph is going to be? Pop your answer in the chat there. Yeah, it's just going to be 3. That's it. So you can kind of see that it could go up or down. It's been stretched upwards by 3, essentially. Okay, now you know that f of x is 3 cos b theta. Now, you need to know what that b is. You know that the b has to do with the period of the graph. And you know that the period of the cos graph is normally 360. And if you divide the normal period by b, you should get the new period of the graph. What is the period of this graph, this green graph that you see here in front of you, this cos graph here? What's the period of the graph you see in front of you? It looks to me like it goes down in 90, and then down again in 90, down in 90, down in 90. So it looks to me like the period of the graph is still 360. Because you can still get one full cycle in 360. So what is B going to have to be? Because think about it. A full cycle of the cos graph is just a up, up, down, down. And so you go from minus 180 all the way to plus 180, which feels to me like 360 degrees. And so B has to be equal to 1. Yeah. So that is that. Okay, we're going to call it a night for tonight with that. So what have we done in the last 4 lessons? So we really learned about trig graphs and how to recognize them. We learned about the 4 different types of transformations and how to draw them. And then in this last lesson, we spoke about how to solve graphing interpretation questions and how to find the equations of trig graphs. And again, I encourage you to practice more and more of these, but my biggest thing I wanted to show you in this unit was how your calculator can be your friend as you go through this process of figuring out these trig graphs. And yeah, so I hope you've enjoyed it and I hope you've learned something. Label, could you put the link to the quiz in the chat, please? I really encourage you to do this quiz so you consolidate your learning. I would also encourage you to re-watch some of the videos. I will talk about trig graphs again when we do the exam revision sessions, and then we'll just do kind of old questions like this where we bring it all together. But the purpose of this 2 weeks was just to build a nice firm foundation for trig graphs.